I am Dan Gaude, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the cyclotomic polynomial and cyclic extension. In cyclotomic polynomial, first concept is roots of unity and cyclotomic polynomials. Now definitions here. Roots of unity. Let E be a field and let n be a positive integer. An element W belongs to E is called a primitive nth root of unity in E. If W raised to n is equal to 1, but W raised to m is not equal to 1. For any positive integer m less than n, consider h is equal to x belongs to C such that x raised to n is equal to 1. Note that first, h is a group under multiplication. Second, h is a cyclic group generated by any primitive nth root of unity. There are exactly 5 of n primitive nth root of unity. For each positive integer n, there phi, where phi is Euler's function. These primitive nth root of unity are cos of 2k pi by n plus I sin of 2k pi by n, where k is a positive integer less than n and relatively prime to n. Theorem. Let F be a field and let U be a finite subgroup of the multiplicative group F raised to n is equal to F minus singleton 0. Then U is cyclic. In particular, the roots of x raised to n minus 1 belongs to f of x. Form a cyclic group. As U is a finite subgroup of the multiplicative group F star, which is abelian, hence U is a finite abelian group. Therefore, U is equal to S of P1 is equal to S of P2 is equal to ... is equal to S of Pk, where coordinate of S of Pi is equal to Pi raised to Ri and P1, P2 ... Pk are distinct primes. We have to prove that S of Pi is cyclic for all I is equal to 1, 2, 3 ... K. Let alpha belong to S of Pi be such that 0 of alpha A is a maximal, say Pi raised to Si, because 0 of A divides Pi raised to Ri, we have Si less equal Ri. Also, for each x belongs to S of Pi, 0 of x is equal to Pi raised to Ri less equal Pi raised to Si. Then x raised to Pi raised to Si is equal to 1 and x raised to Pi raised to Si is equal to 1. Hence, for all x belongs to S of Pi, x raised to Pi raised to Si is equal to 1, because the equation x raised to Pi raised to Si is equal to 1 has almost Pi raised to Ri roots. Therefore, Pi raised to si s1 greater equal p2 raised p1 raised to r1 dot dot dot. Therefore, this implies that s1 is equal to r1, and this implies that pi raised to ri greater equal pi raised to si. 0 of a is equal to 0 of a is equal to pi raised to ri is equal to coordinate of s of pi, and hence s of pi is the cyclic group generated by A. Now we know that if A and B are cyclic group of order m and n relatively respectively with GCD mn 1, then A cross product B is again cyclic. Hence, each S of Pi is cyclic with coordinate P1 raised to Ri R1 and P1 P2 dot 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 Pk are distinct prime. Therefore, GCD of P1 raised to R1, P2 raised to R2 dot 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 Pk raised to Rk is equal to 1. Hence, S of P1 multiply S of P2 dot 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 multiply S of Pk is cyclic, but U is equal to S of P1 multiply S of P2 multiply dot 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 multiply S of Pk. Hence, U is cyclic, and hence U is cyclic.